Okay, I've got vocal. Yep, I'm here, so ready to go. And I know I'm going to have some folks who will come in a little bit late. Oh, not late, but on time, actually. I'm starting a little bit early. So I'm going to be here, and I'm over here today. And once about 3 or 4 more minutes, and then we'll get started. And we'll be ready to go. So it won't be too long, and hopefully OBU has internet access. If they don't, I guess I'll be recording this on my machine, talking to myself. We shall see. So I'll wait to see if we have some folks come in through remote. It's been quite. Hi there. Glad to see you. I'm still a little bit before really starting to roll here. Have I got with me? Hi, Alex. Glad to see you. Dean, glad to see you as well. I am a little early, so I'm kind of waiting on here. And about another 2 or 3 more minutes, and then I'll be ready to go. I hope the two of you are surviving the wind over here in Oklahoma City. The wind is unbelievable. It's gusting up as much as 40 or 50 miles an hour, sometimes a little bit above it. It is, if we had a couple, about 5 degrees higher, this would be Tornado Alley all over again. Let's see what we got. Miles, glad to see you, and Tyler, glad to see you as well. And as I said, we're going to start in about 2 or 3 minutes here. So thank you for being here. I would assume it's just as windy and over there at Shawnee as it is over here. I did some work this morning for one of the churches I did a little bit of work with. Got back over here, and by the time I got here, the wind had started up this morning, but not like it is now. And so we're just a few minutes or so, and then we'll get started, maybe 1 or 2, or I may start now. Well, since we're recording this, and I've got 5 of you here, we're going to go ahead. So expect that we'll have some people join us, which is fine. And I want to make a couple of pitches before we get rolling. The first of all, I want to make sure that for those who might not have ever taken a course with me before, what's over here in the announcements section, and you're typically going to see one of 3 things. One will be my weekly schedule, like you see here. The second will be an invitation, which has the links over to Zoom so you can join the meeting. And the third will be a link to a YouTube video such as this that you can view. Now, I want to encourage everybody, when you view these videos, if you come in here and you sit through the live stream, it's not a bad idea to maybe go back and review, scroll through, and you can also, as far as I know, still get a transcript out of those. I think it's set up to do that. Let me see who else joined us. Okay, glad to see you. Emily, and the iPhone. And we had those issues on, as you're well aware, the issues that we had on Monday. All right. So please do that, and again, you'll note those announcements up there. If I have to change my schedule, typically, well, if I have to change my schedule, I'll send you an email. Well, we're over here in Module 2, but we have been working ahead a little bit. And so that's something that I want to make sure that you understand. If we cover some material, one of these cases, okay, then I just move on to the next module. And I'm kind of front loading things like this because as we go down into the course, if you've had a course with me, you know that I front load a lot so that I can give you a week or two or so to prepare for major projects that I have you do, as well as the final exams, and to give you an opportunity to use class time and leverage that time on a flexible basis. Well, that being said, here's what we had for this week. And one was to review Nolan, which we did that last week, and then we looked at PAR Inc. Okay, and then we looked at M&D Chemicals, okay, which is over, and I also referenced for you the page numbers where we'll find those, and then of course, like I did with M&D Chemicals, I ask you to increase the time percentage of time per product, and if the time available is decreased by 8%. We talked about what we get with that. And so I provided you here's the place to upload PAR Inc., and here's the key for what I wanted you to do, and then here's the M&D key. Now, much of what this deals with, and I'm going to go over to M&D, and it's over in pages 54 to 55. And I'm going to search through the books. I'll do M&D Chemicals. All right. And see, page 54. And here in M&D, that we had a simple minimization problem. As you recall, as we'll hear over and over again, when we use the solver, we can do one of three things. We can try to hit a target value. We can try to maximize an objective function, i.e. an answer, a number, or we can try to minimize. And in this case, M&D is trying to minimize its costs, and they walk you through that process. Okay, and here you see the whole statement for that, with the minimization invoked over here, and then subject to these constraints. And we talked about this in the course, in the lecture. And then here are the feasible regions. Okay, and it's in here. And then they give us a summary of that graphical analysis. Then they begin to talk about the surplus variables and what they mean and how we identify them. Okay, and slack variables. So if you take a look here for a moment at and I'm over in the textbook, I think this is page 57, you can see that we've got these constraints, and the demand for the product, the total production, the processing time. We have no surplus values there, but we do have surplus values for product A, which indicates if we wanted to, we could minimize costs by simply not producing any of product A. Okay, so that would cut costs and it would minimize things. On the other hand, it's not a good business decision and it's not viable. But you could, if you wanted to, run that to look and see if we drop the product line, or if we had to drop the product line. You can use a minimization approach to identify one of those. And we're going to see later on in the course, it's a technique called data envelopment analysis, where we're going to be able to look at facilities within a hospital system, which would be no different, say, than looking at the number of stores, the stores that are out there that are selling food under the name of Burger King or whatever. And we identify those that aren't conforming to a benchmark or a standard. Okay. Now, the text walks us through that process, and then they start to show us the solution. and to show us some of the constraints, the allowable decreases, the allowable increases. This is understanding what you're looking at, and this is from the web file, the lingo. This isn't from the what you would get with Excel, but understanding what they're trying to show you lets you start to say, okay, I have some options here if I choose to operate on a suboptimal level. Now, businesses typically operate on a suboptimal level just because the world's not perfect. It never has been, never will be. It's fallen world, so stuff happens. Things are imperfect. Okay, and one of the ways that we see this is when we try to optimize, and we find that although we believed we could, we've come close, but we've missed the mark. And the biblical part of this is the word sin means to miss the mark. So when human beings as moral agents chose to not trust God, to have their best interests at heart, not only did we fall as moral beings and need to be redeemed and saved, so was creation. And the Apostle Paul talks about that creation waits almost like an expectant mother for Christ to come back and redeem things. So if you take a look here, we see that we've got some allowable increases, allowable decreases. This shows us a little bit of the sensitivity of certain variables to that issue, to that problem, to achieving a solution. Now, I want to direct your attention now down, and let's go down to Module 3, okay, and this is stuff that's next week. And Module 3 is where we're going to use PAR Inc. Continued, and please note, PAR Inc. Continued, okay, is the PAR mod in the Chapter 3 student files. And we're going to explore the sensitivity report in Microsoft Excel. Now, we'll take some time today to talk about that, okay? You know what you need to do for this week or this module. You've got a couple of exams, and you need to upload PAR Inc., okay? And you need to and you also need to upload M&D chemicals. And I've got the keys there for you. Let me stop for a moment. We've had some other people join us. Anybody have a question I could try to answer for you? Anybody? Okay, well, we'll roll ahead then. And down here in Module 3, and we'll talk about this some more next week, but we're going to look at using sensitivity analysis, and we're going to explore that. Now, I have some resources here for you that I want you to take a look at prior to class. Now, when you have an exam like over Chapter 5, you've got to read the text or have the text to take the exam. That's obvious. The application in terms of these case studies that we have, I would try to provide you some supplemental information. So this is over from Easy Excel, and they talk about how we do sensitivity analysis, okay, in Excel, and what that's all about. And what we're really trying to do when we perform sensitivity analysis is to say which variable or which perhaps constraint is most sensitive. Changes in it, what changes, which constraint or which variable that I want to manage will have the greatest impact on the objective function if it occurs. And so they have a nice example here where they show you how to generate the reports in Excel and what they're trying to tell you in terms of what the sensitivity analysis and that sensitivity report will do. Okay, and they give you a very nice example of this And then they talk about the shadow price. Shadow price is a term used in Excel. It's synonymous with the dual value, the term that the authors use as they talk about the additional gain you get with a change in some constraint or some variable that you're managing. What is the marginal utility? It's kind of a measure of that. And so that's a good resource for you, and I hope that you will pursue it. I have another resource here for you, and this talks about shadow price, using shadow pricing in linear programming. Okay, and this walks you through how we can determine a shadow price or a proxy for what we'll pay or what we'll gain or lose given a set of constraints. Shadow pricing came into vogue in the late 70s and early 80s when economists, they were some of the first group of people, said, okay, what if we're going to make a trade-off? Say, let's take the Western United States. A lot of it's owned by the government. It's set aside, and there are areas where inside of those government lands, there are people who are basically renting the place, renting parts of it to farm, to ranch, to log, and economists say, okay, well, if we're making trade-offs, what does it cost us or what do we gain? And so they walk you through this whole process of a shadow price when we say, all right, as they tell you, the shadow price, they bold this for you with a resource tells you how much more profit you would get by increasing the amount of that resource by 1 unit. It's basically another format in terms of marginal utility. Okay. Now this is very important, and there's a reason why. As I've emphasized throughout the course, when we make a decision, it's not binary. That decision it's neither black or white. It's really a continuum of gray. And really good stuff that happens, really bad stuff that happens, or, well, what we figured out probably would happen. And the outcomes of our decisions are on what we call a continuous basis. They're not discrete. There's no right answer or wrong answer. There's a series of right answers, a series of wrong answers. It's just the degree of severity or magnitude. And that's important for us to understand. And I've emphasized that, and as we see these constraints, that's important to keep in mind. So the sensitivity analysis lets us take a look at constraints and or variables, and how do changes in them change the objective function, i.e. the answer that we get. And this just follows along. When you go through the text and you read a chapter and you see those graphic representations of the feasible area, that's all they're really saying. But if you think about it for a moment, a line segment, and you'll see those, or a line, has an infinite number of points. So in truth, when we take an action, there are theoretically an infinite number of outcomes that we can get. And that's important for us to understand. So we try to figure out, well, what's the most likely outcome? And that's why I've said we use randomization tools to simulate those kinds of experiences, and to simulate those outcomes, because we could randomize on an infinite basis. We could do 1,000 trials, 10,000, how many we want, and see what it looks like. That's the value of a mathematical model that we know is grounded in some reality. And so the sensitivity analysis is a way for us to see how we can, the types of changes that are produced. And when we identify a sensitive constraint or a sensitive variable, that lets us focus on it from an operational standpoint. And I'll give you an example. If we find that the sales, let's say that we set up an objective function in terms of the amount of, and I'll just say about a case we have a case where we're an advertising agency, and they're going to try to say, okay, how do we get the maximum exposure for the lowest cost? In other words, we want to optimize that. And as we look through that, we'll find that there are some media ways of reaching people that are that have a big impact on the outcome. And so when we do sensitivity analysis, we can identify those, and we can say, okay, this is something I need to manage closely. And that's running Solver, understanding the algebraic proofs that are provided in your text through the linear graphics, those linear graphic lines, and all of that. Those things are telling you about decision making, and that decision making really has to be viewed in terms of a continuum. Now, you'll hear this from me over and over and over, and you'll go, why don't you shut up about that? And the reason I won't is this. I want this embedded in your skull, tattooed to your forehead, deep inside your gut when you're making a decision, to understand that it's a range of outcomes. If you have a good sense of the probable variation, and you think you're within 1 sigma plus, 1 sigma minus, or let's call it standard deviations, you're dealing with normal data, you're fine. Okay? And so far we've been doing simplex LP. In other words, we've been assuming that the coefficients of these outcomes are like follow a linear trend. And you'll recall, if you took 1123 with me, business problem analysis, we had that case where we had folks who were I think they were manufacturing chips or something of that nature. But as you charted the data, the more of those they made, the greater the higher the number of defective parts, which said, we got a problem, we've got to deal with it. And we used regression analysis to say, okay, if we made, I think it was like 20 million or something like that, well, then how many defective parts do we produce? Same principle here. The other is, because of sensitivity analysis, because we see that outcomes can vary, and can vary widely under the right conditions, this leads us to understand this thing called the law of unintended consequences. Okay? And it's just simply, it's the law of unintended consequences. And these are things where we make decisions, but we never really understand what might happen. And this is one of the terms that people will use, is the black swan effect, which means things just go disastrously wrong. Nothing goes right. And there's a book out there, The Black Swan, a guy he's an expert in probability theorem. He was a trader. He kind of tracked what happened when Wall Street melted down, had the meltdown in the mid-2000s, in the first decade of the 2000s. And he talked about the black swan. And that is where everything that can go wrong goes wrong. Okay? So I know I'm being a little more didactic than usual, but we're not just going through empty exercises here. I'm showing you some real world pictures and trying to back it up with some theory and some practical example of decision making. Management science at its heart is about making decisions, and making decisions that are based upon some goal, i.e. the objective function, some set of variables that we're going to change to achieve that that objective function, and the set of constraints under which we operate. And that's really what decision, at its heart, that's what it is. And this course is really, it's about the management science part, but it's the decision making as well. Okay. And we'll go ahead and we'll take a look. Now, before I go on, let me encourage you, just for fun, go out on the internet. And I'm speaking with you like this because many of you, well, you're on your way to heading out the door to go out and run somebody's business. And I want you thinking like this because you're going to be playing with other people's money as well as your own career. And I want you to be thoughtful when you make a decision and to use the best tools you can, but also to be understanding what decision making really entails. Go out and study the Monty Hall problem, Montyhall. You've probably heard of this problem, or Monty Hall had a show called The Gong Show. I think that was it. And it was one of these game shows where people dressed up crazy and then he asked them questions. If they won a round, they had this thing of they were given 3 doors, and behind one door was kind of nothing. The second door was there was another door that was kind of not such a good prize, but a prize. And the third was a really fantastic prize. And so Monty would start them off with 3 doors, and he would say to them, okay, which door do you choose? And let's say the person chooses door number 3. Now remember, we're thinking here probabilistically. This first round, I have a 1 in 3 chance of getting it correct, don't I? Yes, I do. 1 out of 3. So let's say I guessed correctly. All right. And then I guessed correctly, but I'm given, it's the so-so prize, and I got another shot. He'll give me a second chance. What are my probabilities of choosing? If you go with just a straight Bayesian approach, your probabilities now are not better, they're worse. You had a 1 in 3 shot at first, now you have a 1 in 2 shot, and 1 out of 2 is 50%. And you would be surprised that decision makers and all kinds of people who, that Monty Hall problem is one that really blows people away. But the truth is if you just use simple Bayesian probability, you're going from 1 to 3 to 1 to 2. And so if I go from 1 to 3 to 1 to 2, I've gone from a 33% chance, okay, to a 50% chance, yes, of getting it correct. That's true. But I also have a 50% chance of getting it wrong. So my odds of getting it wrong are now equivalent. They're not better. My odds of getting it right are not improved, because I still can get it wrong. That's the Monty Hall problem. You can go out and read it. There are mathematicians and folks who've been talking about that and writing papers about that and dealing with it for as long as you can guess. I think Dr. Marimi just recently published a paper. I think they did Family Feud, but it's an interesting thing to talk about, but it's part of decision making and part of decision science. Now, as we look at that shadow price, and we talk about some of these unintended consequences, okay? And I often cite the housing crisis as an unintended consequence of a well-meaning federal government trying, and 2 or 3 different presidents trying to push get more Americans to become homeowners, with the belief that home ownership is the key to wealth for most people. Okay, it's how they accumulate something. This is a nice little article about shadow pricing and using that in terms of running businesses on a green basis. I want to take a look at it. And then there are some other resources I've got for you. One about decreasing congestion using driverless cars. And then for those of you who might be finance majors, if you take this course, this talks about the geography of the efficient frontier. When you put together a portfolio, okay, there is a thing known as the efficient frontier, and that is a line. Typically, it's either it's concave, or it could be convex, I guess, if you're shorting things. It's a demarcation between the point where your portfolio is as balanced and risk-free as it can be. In other words, it's optimal. You have an optimal portfolio. And so this efficient frontier provides us a way to think about portfolios. Do we have the best combination we can get? And then I also have here if you're not a finance major, but you have had intro, maybe it blew by you or whatever, you want to take a look at this. This is an excellent resource that will explain that whole idea of portfolio theory and the efficient frontier. Portfolio theory is based on the idea that I get a collection, I invest in a collection of assets that are counter-cyclical. In other words, I have a collection of assets that in some conditions they're going to go up and others will go down, and I offset that and I balance my portfolio, and I find that efficient frontier where I have the most efficient portfolio possible given the mix of assets I have and their risk and rewards. Okay, so I encourage you to take a look at that. Even if you're a management major, you could say this is very much like or a marketing major. This is much like a product service bundle or a product mix that I have at my company. So there's a lot here as we move into this issue of sensitivity analysis, and a lot here for us to think about just in terms of how we make decisions. And I really can't emphasize that enough. If we had a degree, if we had a concentration in management science, we'd have this course, we'd have a logistics course, we'd have an intro to decision sciences course. We probably would have a course. We would need to have a course on simulation, and I've named 3 or 4 there, and probably then some kind of a capstone, and probably an advanced statistics course. Although there are tools out there now that help us use them. But if we had that, I would say also the production. You'd have to have a production analysis course as well. Maybe a service analysis course or a service theory course, and also incorporate some concepts from quality assurance and quality control. Okay, so this course intro is just the tip of the iceberg. Okay, now we'll go back over here, and I'm going to close this off for just a second. All right, and we'll go back into, and let me go into the canvas again. I'd thrown myself out for just a sec. And we're over here, and as I said, we're jumping ahead a little bit, and let's take a look at what we've got here. Now, again, let me make sure that you understand. PAR Inc., okay, and that's pages 149 through 151, but you're going to use a file called PAR Mod, and that's in chapter 3 in the student files. Okay, so you'll want to take a look at that. And then we'll explore the sensitivity report in Excel. What do we see? What do we get from it? Then there's also the Hewlett case, okay, and that's from that's in chapter 4 in the student files. Now, I want to take a look for just a moment, and let's talk about the let's talk about Hewlett, okay? And I've got a file here called Hewlett Key, so I'm going to open it up. And then I'm going to download it. Now remember, when you get ready to upload this, you're going to need to save it to your desktop, probably rename it, then open it, then save it, and then upload it again. I'm going to enable the editing on this. Now here we're given a sensitivity report, okay, for Hewlett, and we'll scroll this down, look at the tabs that are down here, and notice that we've got this. I'll have to open this up all the way. Here's our original solution, and I had asked you to play with the variables a bit and use the solver to compute the cash flows and the minimum funds due. This is an annuity program or of some type, or an insurance company. I'll have to take a look at the details, but the point is they're trying to make sure, they're trying to figure out what are the minimum amount of funds we need to have on hand in order to meet these yearly obligations. And so I said, okay, let's take that file and increase the price of the bonds, go up 2.5%, and that would be one scenario. Then a second scenario would be all three bonds decrease 2.5%. Okay, and we could work this through. You've got three bonds there, and we have two scenarios here. All three bonds go up, or all three bond prices go down. We could have a third scenario where we look at one goes up and the others, number one goes up and the others stay constant. One goes up. There are about 9 permutations you could work through this to see. And again, I would probably do that if I were trying to actually fund something like this, and you were doing this for real. Okay, because if you can't pay your obligations on those bonds, you have a serious problem on your hands. Well, nonetheless, you can see here the cash requirements by each year, and then the model. Okay, and we'll talk about this some on Monday and go through it in some greater detail. And then the minimum funds that we need, and then our cash requirements, and we have our constraints for a yearly basis. Now I'm going to click on Data and go over to Solver. All right, and you'll see I'm going to set the objective function cell is B20 by changing the variables A17 to L17, and that's these periods. And then I have constraints G21 to 21 to 28 and I 21 to 28. And notice we have all equivalencies here. Okay, so we're assuming that the net cash flow is going to equal the cash requirement, and we have these investments in the cash inflow. You can see the constraints there based upon year by year the inflows, the outflows, and it's a capital budget. This is really a capital budget problem, but we're going to use the solver here to try to get the minimal amount. So why would you want to have the minimum amount of cash required? It's pretty simple. I want to make sure I can pay these annuities or these bond holders, okay? But cash is inventory. It's just monetized. It's just in a form that's easily liquidated, moved, and a store of wealth. So if I'm here, I want to minimize how much I pay. I want to make sure I have the minimum necessary to pay out each year. So if I can find some surplus or some slack, I can invest that as a hedge against any unforeseen consequences, unforeseen conditions that might arise. Because this may not work, this may not work like clockwork. So we'll talk some more about this on Monday when we have class, and Lord willing, the internet will be up. And we'll walk through the sensitivity reports, then a bond price decrease, and a sensitivity report for it, several of these. And as I mentioned before, we've got 3 bonds, and they can go up or go down. The bond price, you could, I guess, if you want to, say the bond price will stay constant. So you can figure out the permutations that you have. Okay? So there's a lot of possible outcomes that you could get, and you want to try to plan for that. And again, we'll talk about this some in terms of what is the sensitivity analysis, what does it tell me, and I would recommend that you take a look at that, at that part of the text, as well as those resources I have for you there. And I'll go back over here to the modules. These resources for week 3, module 3, excuse me. You have the chapter 5 to read. You have the materials around the cases to read, like Par Inc. continued, as well as Hewlett. And I identify the pages where those cases are covered. But I also really do want you to take some time and go over and take a look at these resources that tell us about sensitivity analysis. This is where Solver and tools like it become exceptionally powerful, because I can start to identify those variables or those constraints where a change in them can provoke sometimes some really big changes in the objective function. If you want me to put it in management terms, it's a term that people call managing by exception, okay? And when you go to work, you're going to find that when you're managing things, especially the higher you go, most of what you'll run into is going to be putting out fires and dealing with problems. The other stuff that just happens like it should is not going to land in your email or on your desk. It's just going to be wrong. It'll be the exceptional things. And so this is a tool that lets us identify some possible exceptions that could produce some really good results or some really bad results, i.e. Take our objective function in a direction we don't want to go, or get us so far off of target value that we really cannot at all recover. Okay, so I really want to encourage you to take a look at that information. Now, we've got a little bit of time here. I started somewhat early, so I'm probably somewhere around about 35 or 40 minute mark, somewhere in there, and we're to go 50 minutes. So if you came in a little bit late, you can always double back. You can always double back and see the beginning of this thing once I process the video. I want to just take a few minutes, since we've got a little bit of time here, to give you an idea of where we're going to head on, and we'll be heading then into a series next. And when we hit module 4, we're gonna see the true versatility and why Solver is such a tremendous product, and why thinking, okay, optimality, thinking of that is such a superior way to think about the decisions that you make. And you're going to see Solver applied to several different kinds of problems, business problems, There's not a single discipline in here that we have in the College of Business, econ, management, marketing, international business, any of those that are not subject to this model. That's why it's so and that's why it's so important. We think about the term management science, okay? It says we're using a scientific approach where we try to build a model of the world and based on we try to build a model of how things work, and then we experiment or look at it. Now, the nice thing is because we have this tool, we can simulate things before we ever have to actually put them into operation, so we can have a decent idea what's going to happen. I'll give you a really good example of this. The New York Times has an article, I think it was either New York Times or LA Times, one of the two of them, but they have an article about these light plastic bags now that Amazon uses to send stuff. The plastic is lighter than a traditional small box that they would use. This is stuff less than what will come in your typical Amazon box. Let's say you order cosmetics from them, or you order soap or something that can be put into one of those small plastic pouches. Well, they love them because they can get a whole bunch of them. They can carry them, and they're much more energy efficient because they're so light. Okay, so you're not adding too much weight onto the product you're already shipping. And at the scale Amazon operates, they really have to be mindful. However, an unintended consequence of it is that the plastic gets caught in recycling machines. And so when folks are recycling those materials and those plastic containers get thrown in there, they gum up the machine, and they have to go in and cut the stuff out in order for the machine to continue on chewing up cans, cardboard, or whatever else is put in there that's recyclable. So there's an unintended outcome when they made an attempt to optimize, and they've achieved tremendous savings in terms of fuel consumption and in terms of use of wood products, but they have a problem because as they run it through the recycling mill, the stuff gets caught. So it's an interesting thing to take a look at. And again, sensitivity analysis starts us down that road of thinking and understanding that the decisions we make, the outcomes may surprise us. Hopefully they won't. If we've done our homework, if we've had due diligence, if we've been lucky enough to have some good data, then it won't surprise us like that. But we can be prepared for a surprise. For example, in the Hewlett, one of the reasons I want to minimize the cash outlay is so that I can take excess cash or have excess cash and invest it as a hedge against everything falls apart. Well, folks, listen, I really do appreciate it. And I see we've got 16 in here. I think we've got a whole lot more folks, but I'm certain everybody else is going to take a look at this thing between now and noon tomorrow, which they need to do to be attending. Let me stop for a moment. I've been going. Anybody have a question I could try to answer for you? Anybody? Very happy to answer a question if you have one. Okay. Well, then I'm going to end the recording and everything and process it. I'll have it posted there by this afternoon. I also want to encourage you, one final thing. In my schedule, you'll see, and over in your announcements, you will see, a link to virtual office hours. I have virtual office hours today, if I'm not mistaken. Let me open up my other machine here for just a minute. I think I have virtual office hours from 2 till 6 p.m. You're very welcome to visit to see what's going on with that. It's just basically I have a room open for all intensive purposes. You come in. If you got a question, I can answer it and all that business. You do have privacy in that I do not, under any circumstances, post office hours. I record them, okay, but I don't post them. And if you come in, you can ask me a question or make a comment through the chat function, and that chat function is invisible to anyone except me and the person who is asking the question or making the comment via chat. So I encourage you to come by and see it, try it. You might find I can do everything there versus the only thing I can't do is sign something. So those virtual office hours are there for you to help you if you have some questions or problems. Folks, thank you so very much. And I will see you Monday. And God willing, the server will be up and we will forge ahead into module number 3. Thanks so much.